Okay, we're going to review properties of exponents. In our first problem, we have b to the third times b to the seventh. We're multiplying like bases, so the rule to add the exponents of the like bases. B is your base, 3 and 7 are your exponents. 3 plus 7 is 10, so your simplified answer is b to the 10th. Okay, here we're multiplying two monomials, but we have coefficients as well as bases with exponents. So what we're going to do is we're going to multiply the coefficients at 3 and 5. So we're going to multiply 3 times 5. Our exponents have like bases, so we're going to keep the a and add the exponents, 8 plus 15. And we're going to simplify. 3 times 5 is 15. 8 plus 15 is 23. So your answer is 15a to the 23rd power. Okay, now here we're still multiplying, but now we have a power raised to a power. One base, two exponents. Your rule here is to multiply your exponents. So this is going to be y to the 3 times 5. So it's y to the 15th power. All right, here we have a monomial that's raised to a power. So this exponent on the outside has to be multiplied by the exponent of every base on the inside. If we don't see an exponent, it's understood to be a 1. Every base has an exponent. So this is 2 to the first, x to the second, y to the first. So the rule says to multiply your exponents. So it's going to be 2, 1 times 4, x raised to the 2 times 4, y raised to the 1 times 4. When we simplify, we have 2 to the 4th, x to the 8th, y to the 4th. We can simplify 2 to the 4th by multiplying it out. 2 to the 4th is 16, x to the 8th, y to the 4th. And we got 16 by multiplying 2 times 2 times 2 times 2. Okay, so now we have some fraction bars. Fraction bars indicate division. So now we're going to divide using our exponent rules. You look at your coefficients and we see if we can simplify or reduce the coefficients. So we start by reducing the coefficients. Here we have a 2 and a 3, cannot reduce, so the 2 and the 3 remains. In order for an expression to be simplified, we cannot have negative exponents. The negative exponent tells you about the position of the variable. If it's in your numerator and it's negative, it means it needs to go down to your denominator and becomes positive. If it's in your denominator and it's negative, you need to move it up to your numerator and make it positive. So this x to the negative 5th is in the numerator, but it's negative, so it's going to come down to my denominator and become positive x to the 5th. Y to the negative 4th is in your denominator and it's negative. We need to move it up top and it becomes positive y to the 4th. This is your simplified answer. We know it's simplified because 2 and 3 cannot be reduced and y and x are not like bases. Okay, here we have another fraction. So we're going to start with the coefficients. 25 and negative 15. We can reduce those by dividing by 5. And you're going to have 5 and negative 3. I have m to the 4th on top and m on the bottom. When we're dividing, we're going to subtract the exponents. The subtraction takes place wherever the highest exponent is located. So for my m, I'm going to do 4 minus 1 in the numerator because 4 is greater than 1. For your n, you're going to subtract in your denominator because 6 is the greatest power. So 6 minus 1. When you simplify that, your final answer will be 5m to the third negative 3n to the fifth. Now, a negative in a fraction. The fraction is negative regardless of the positioning of this negative. The negative can be in the denominator, or we can write the negative 5 by putting a negative with the numerator, or we can put the negative out front. One negative in a fraction means that that fraction has a negative value. So all three of those are equivalent solutions. Okay, we have a fraction bar, so we're dividing, starting with the coefficients. We have a 12 and a 4. 12 and 4, you can reduce by 4, or you can just say that 4 can go into 12 an even number of times. That 3 goes in the numerator because 12 is greater than 4. Now I have an x to the first power and an x to the fifth power. We're dividing, we're going to subtract. That subtraction occurs in the denominator because 5 is greater than 1. So your answer is 3 over x to the 4th.